Alright, today let's talk about section 1.4. Here are your objectives for section 1.4. Add and subtract complex numbers, multiply complex numbers, divide complex numbers, and perform operations with square roots of negative numbers. Anybody remember what complex numbers are? It's with the I, right? Do you remember that part? Okay. So a complex number looks like this. A plus BI. The A is the real part, and the BI is the imaginary part. Okay. Well, I need you to remember where the I even comes from. Why do we even have the I?
Doesn't that have to do with square roots? Like a negative square root?
So if I take the square root of -1, that equals I. And that comes from, if I have an equation I'm trying to work on and I get to I squared equals -1, to solve for I have to take the square root of both sides to solve for I, and that gives me I equals the square root of -1. So a lot of times we define I squared as -1. Because at this point, if I do square both sides, I get -1 equals I squared.
So VI would be B times -1.
Yes, and that's the imaginary part of the number. So if I have 2 plus 3i, which is the real part? The 2, and which is the imaginary part? 3i, okay? There's a thing called the equality of complex numbers. And the equality of complex numbers says that a plus bi equals c plus di if and only if. See what I wrote there? IFF. I didn't spell if wrong. This is a mathematical shorthand for if and only if. Okay? If and only if A equals C, God bless you, and B equals D. Okay? So A plus BI will equal C plus DI if and only if, perfect, A equals C and B equals D. Now that helps us figure stuff out when we're trying to add or subtract, or multiply or divide for that matter. Okay? Because if I tell you, not A, 2 plus 3i plus 4 plus 5i, what is that going to equal? Well, how do we add complex numbers? Add the real part. What's 2 plus 4? 6. And then add the imaginary parts. 3i plus 5i. 8i. Okay? We know that that's true because of this equality of complex numbers. I can take the real parts and put them together because these two A values are going to equal this C value, and the two B values added up will equal the D value. Okay. Same way it works with subtraction of complex numbers. Okay. If I do 2 plus 3i minus 4 plus 5i, I just have to be careful to remember that I'm subtracting the entire complex number of the 4 and the 5i. So I would do 2 minus 4, which is -2, and 3i minus 5i, which is -2i. That's what most people forget, is subtracting this, especially the imaginary part. Okay, we could rewrite this as 2 plus 3i minus 4 minus 5i, couldn't we? If that's a problem for us, because all I did was distribute the -1 that's right here, there, and there. You okay with that? Okay. Multiplying complex numbers. I can start with something as simple as this. Whoops. That's supposed to be just a 3. This number out front is called a scalar. I don't know why. That's just what it's called. If it's just a real number multiplied, or even if it was an imaginary. multiplied. I still distribute it just like as if this was like two different terms in a parentheses. Okay? So 2 times 3 is 6. 2 times negative 4i is negative 8i. Why do I keep doing that? 3 plus 4i times 5 plus 6i. That's my favorite one. Those of you who I didn't have in class last year, that's my favorite one. That's what I was called when I was little. 4i's. Yeah, okay. How do we take a complex number and multiply it by a complex number? Well, could you do something like this? X plus 2 times x plus 3? That's not complex. I just distribute each term throughout the problem, right? That's all I do here. I say real times real, real times imaginary. Imaginary times real, imaginary times imaginary. Same concept, different topic. Okay? So 3 times 5 is 15. 3 times 6i is 18i. 4i times 5 is 20i. And 4i times 6i. Now what do I do there? 24i squared. That's exactly right. Okay? But now I got to combine like terms, right? Are those my only two like terms? Well, remember back up here, what does I squared equal? Negative 1. So this is really times a negative 1. So that's really negative 24, isn't it? So can't I combine the 15 and the negative 24? I can. So what do I get when I combine 15 and negative 24? Negative 9, and then combine the imaginary parts. 38i. Now, that being said and shown, let me show you something else. Home, new document. No, I don't want to save the old one. Calculator. I'm going to start back up here. 2 plus 3i. Everybody see where I got the I? It's right here where the pi is. If I press it, that thing opens and I choose the I. Okay? 2 plus 3i plus 4 plus 5i. Oh look, that's exactly what we got. 2 plus 3i minus 4 plus 5i. Now, notice the i's right now. That's the I that I got from here, right there. And that's the I from the letters, this letter I. You think it's going to work? No. Variable is not defined. It sees that, the calculator sees that I, this letter I right here, as a variable, like something you have to solve for. Is this I right here a variable? No, this I right here is representing imaginary, so don't try to interchange those two because it's not going to work. I want to use that I, and then you get negative 2 minus 2i, which is what we got here. Okay? Now, those two are pretty easy, right? It's this the other multiplication stuff that you might save a little time by doing in your calculator. Of course, you know that I want you to be able to do it by hand if you were asked, but isn't this at least a good way to check? Yeah? Okay, yes sir. I suppose, but then if you needed it for something else, or if you were trying to use it in a different part of the problem, it wouldn't let you. Okay? Now, your calculator may not work. Let me see if this other calculator will work. I'm going to show you something. if I did 2 plus 3i, and then plus 4 plus 5i. Yeah, it worked. Most of the time they need to be in the right mode, okay? So you might have to check the mode by going to your settings. From home, you can go to your settings, number 5, and looking at your document settings. See, this one's actually set on real and not complex, right? So the cool part about that is if I did the square root of negative 25, you guys and I know what should that be as the answer. What's the square root of 25? 5, and then with square root of negative 1, I, so it should be 5i. But I'm in the wrong mode. It's telling me it's not real. Well, I know that because we're talking about complex numbers, right? But the calculator won't do it for you unless you're in the right, correct setting. Excuse me. So if that's something you want to be able to do on your calculator, you're going to have to go change your settings to be complex instead of real. Okay. I don't even think it says complex. Let me show you what it says. Document settings. Rectangular is where it needs to be. Okay. So if I start a new document now, and that's a calculator, and I do the square root of negative 25, now it says 5i. Okay? Does that make sense? So it just has to be in the right setting. All right. So far we've talked about adding and subtracting complex numbers. That's probably something I figured you could do by yourself, but I just wanted to show you a couple of examples. Multiplying complex numbers, yes. What about dividing complex numbers? Do we need to talk about that real quick? Okay. So, that's a good question. I'm gonna do one in the calculator real quick to make sure that I'm answering the right, or telling you the right answer. But of course, you guys know I want you to know how to do it by hand. So number one, yes, you can do it in the calculator, but I need to make sure that you understand how to do it by hand. Okay. So if I give you something like this, 3i over 4 plus I, if that's our sample problem or a problem that we're having a grade on or something like that, we can't have imaginaries in the denominator of a fraction. Okay? We want to simplify this if at all possible, and it's possible. So what we need to know is we need to know the complex conjugate. Anybody remember talking about that in Algebra 2? Complex conjugate? So the real part stays. Complex part is opposite. Exactly right. Okay. So the real part stays and the complex part is opposite. So it's 4 minus a. Excuse me, 4 minus I. Does that make sense? Well, I need to multiply that by this denominator right here to be able to get rid of the complex part in my denominator. But if I just multiply it by the denominator, I've changed the value of the fraction, haven't I? So how can I multiply by the denominator and not change the value of the fraction? Multiply it by the numerator as well. Very good. 4 minus I to the numerator as well. Okay? So, in the numerator, I have 3i times 4, which is 12i. And I have 3i times negative I, which would give me negative 3i squared. But I squared equals negative 1. So it's negative 3 times negative 1. So I have 3 plus 12i. Now, why did I change it around? Do you remember? We like to put it in standard form. In all of algebra, we like stuff in standard form, right? In the regular, general, plain old form that we might see it all the time when we're using complex numbers in our real world job. Sorry, that was a little sarcasm. Sorry about that. Okay? But we like it in standard form. We like the real part first and then the imaginary part. Okay? So for the denominator, does it just go away? It doesn't just go away, does it? We say 4 times 4, what is that? 16. And 4 times negative I. Negative 4i. And then we have I times 4, which is plus 4i. Oh, nice. And then I times negative I squared. Now do you see why we choose the complex conjugate? Because look what happens to those middle two terms. Yeah, that's 0, isn't it? And what does I squared equal? So I have a negative 1. So plus 1. So it's 16 plus 1. 17. I choose the complex conjugate because now I don't have a complex part of my denominator anymore. Is it okay to have 17 in my denominator? Yeah, I just can't have a complex part. Can't have an imaginary part in my denominator. Okay? Now, I need you to be careful about this. Okay? Your My Math Lab settings, I don't know. You'll just have to try it. Okay? It might take this perfectly fine. It might want this. What did I do? I put both parts of the denominator, or excuse me, of the numerator over the denominator. These two are equivalent answers. Okay. Sometimes your computer doesn't like that as an answer and it wants it as two separate parts. Does that make sense? I mean, kind of, because it doesn't really make sense to me, but whatever. Okay. So, of our objectives, we've talked about adding and subtracting, yes. We've talked about multiplying and dividing, yes. And then last one is perform operations with square roots of negative numbers. Well, like what? Well, what about the square root of negative 18 minus the square root of negative 8? Do you know the square root of negative 18? Yeah, I don't either. Okay, but I do know that the square root of 18 is the same as this. Isn't that the same? Why did I choose 9 and 2 and not 6 and 3? Do I know the square root of 9? Yeah, I do, right? So do I know the square root of negative 1? That's I. Okay, do I know the square root of 9? That's 3. So I can pull a 3i out of that square root sign, and all I have left is the square root of 2. You okay with that? The negative 1, the square root of negative 1 is I. So I can take out the square root of negative 1 as an I. That's where I get it from. And I take the square root of 9 and I get 3. And all that's left inside the radical is the square root of 2. And I don't know the square root of 2, and I don't know a multiplier of the square root of 2 that I know the square root of. Okay? Can I do something similar with this? Well, the square root of negative 8 is negative 1 times 4 times 2, right? Why did I choose 4 and 2? Because I know the square root of 2. I mean 4, not 2. Definitely not 2. Okay? What's the square root of negative 1? I. What's the square root of 4? 2. What's the square root of 2? I don't know either. But here's the deal. Now I have this kind of like, you know how when we do adding or subtracting with variables and I can say 2x and 5x and that's really 7x? Same kind of rules apply when we're talking about radicals. If the radicals are the same, I can mess with those numbers in the front. Do I know what 3i minus 2i is? 1i, right? Or just I? And then I just have to keep that square root of 2 with it. So that's what the objective means when it says perform operations with square roots of negative numbers. It's basically just simplifying the square roots if you can. And then just performing operations like addition, subtraction, kind of things like that. Okay? Do I need to do any more of those? I can do 2 more, 1 more, 7 more.
Wasn't that factoring in?
Will it ever get to multiplying with that crap? Yes. Yes, it will. Okay. Yeah, I'll show you one just so you have it. Negative 1 plus the square root of 5 squared. How about negative 5? That would be better. So if I have negative 1 plus the square root of negative 5 squared, what does that mean? Isn't it that times itself? So negative 1 plus the square root of negative 5 times negative 1 plus the square root of 5. Negative 5. This is just distributing, right? So negative 1 times negative 1 is 1. That really took way too long. Negative 1 times the square root of negative 5. Negative square root of negative 5. What about this? That's another negative square root of negative 5, right? And then what about this? Isn't it just negative 5? Because it's the square root of negative 5 times the square root of negative 5, which would be the square root of 25, which is 5. Oh, that's kind of tricky though, isn't it? Because it would be, it's just tricky. You just got to look at what's going on. Okay? So, now what? Because we're not done. We got 2 of these, right? So 1 and negative 5, I can go ahead and combine that to be negative 4, right? Not equals. What's wrong with you? Minus 2 square roots of negative 5. Do I want a negative under my radical? Can I simplify it like I did the 8 and the 18 up here? Not really, right? There's no root of 5 that I know, but I do know for sure the negative 1, don't I? Okay, so what's the square root of negative 1? So just like that. And then I'm done. Now, can somebody tell me why this number right here is not a positive 5? Because remember, if you're multiplying square roots, you multiply the numbers and then you take the square root of it. Well, negative 5 times negative 5 would be positive 25, and the square root of positive 25 is 5. So why did I write negative 5? That's what's in the radical. Okay? That's what's in the radical. That's why we left it as negative 5 right there. Okay? And that's the answer. Okay? Got it? Do I need to do any more? Feel comfortable?